bells will next ring. The bells will next ring together at 11 p.m. Find the time the bells last rang together. Find the time the bells last rang together. Okay, now let's go straight to the solution. Now, before we start solving this question, let's analyze it first. We have three bells, and they are ringing at an interval of 9 minutes, 15 minutes, and 21 minutes. Now, the bells will next ring together at 11 p.m., but the question is asking us what time did the bells last rang together. Now, here we're going to involve the LCM. Now, we're going to find the LCM of 9, 15, and 21. LCM of 9, 15, and 21. First of all, we're going to find the factors of these numbers. The factors of these numbers, we have 9, 15, and 21. Now let's see the factors of the following numbers. Now for 9, we have 3 times 3. 15, we have 3 times 5. And for 21, we have 3 times 7. Now from this, we can find the LCM. From this, we can find the LCM. I believe you're familiar with this method. Now we find the LCM. Now the LCM from this will be 3 times 3 times 5 times 7, giving us 315. But first of all, from this we found that we have 315, but we are finding the LCM of the minutes. So we'll convert them into hours. Now let's convert them into hours or into time. So we'll find 315 divided by 60, because 1 hour is equals to 60 minutes. So calculating that, we'll find that we have 5 hours and 15 minutes. 5 hours and 15 minutes. I believe you know how we have converted further ahead there. So we have 5 hours, 15 minutes. Okay, now this is the time that the bells took. So from the question, the bells will next ring together at 11 p.m. So we need to find out what time did they last ring together. So how do we do? We minus. So that is 11:00 p.m. minus the time that we have here. So that is 5 hours and 15 minutes. So subtracting that, you get when you borrow 1 hour, you get there 60 minutes. So 60 minus 15, that is 45. Again, you remain with 0 there. So 10, borrow here on 1 hour there, with that 10. So that is 10 minus 5 will remain with 5. So we get that the time they last rang together was 5:45 p.m. Okay, now that is that. Let's go to the next question. Let's move on to the next question. Now we're going to tackle majorly just LCM and GCD. Then next time we'll look at something else. Okay. Okay, let's move on to the next question. square room is covered. A square room is covered by a number of whole rectangular slabs of size 60 centimeters by 42 centimeters. Calculate the least possible area of the room. Calculate the least possible area of the room in square meters. Okay, now let's put on a solution. Okay, now first thing, as I say, we analyze the question first. We have a square room. It's covered by a number of a whole rectangular slab size 60 by 42 centimeters. Calculate the least possible area of the room in square meters. Now, here we'll do the LCM of 60 and 42. LCM of 60 and 42. Okay, let's solve and find the factors first. Factors, so of 60 and of 42. Now what are the factors of 60? We have 2 times 2 times 3 times 5. Let's confirm this. 3 times 5, 5 times 3, that is 15. 15 times 2, 30. 30 times 2, 60. Correct. Let's move on to the next one. 2 times 3 times 7. 2 times 3 times 7. Let's confirm it. We have 7 times 3, 21. 21 times 2, that is 42. Now this brings us to our LCM as 2 times 2 times 3 times 5 times 7. 2 times 2 times 3 times 5 times 7. Okay, now multiplying this, you get 420. Multiplying that, you get 420. Multiplying that, you get 420. Now, this 420 is just one side of the square. Just one side of the square. So, what do you know about area of a square? An area of a square is side times side. So that will be 420 times 420. Now multiplying that, what do you get? Get 17, 64, 00, but in centimeters squared. But the answer wants, but the question wants the answer in square meters. So what do we do? We change this into square meters by dividing by 10, by 10,000, yes. So 6400 divided by 10,000. So we'll have 17.64 meters squared. I believe you know how I've converted. Because 1 meter is equals to 100 centimeters. So that means that 1 square meter is equals to 10,000 centimeters squared. That is how the conversion has been done. Okay, let's move on to the next question. Let us move on to the next question, guys. Let us move on to the next question. Now the next question says that three lengths not three lengths, not three lengths. The length of three wires, were 30 meters, 36 meters, and 84 meters. Pieces of wire of equal length, pieces of wire of equal length, were cut from the three wires. Calculate the least number of pieces obtained. Now, solution. Okay, when I ask the question first, the lengths of the three wires were 30. So the lengths are 30, 36, and 84. All of them in meters. Now, pieces of wire of equal length were cut from the three wires. Calculate the least number of pieces obtained. Okay, now here again we'll do the GCD. So we'll do the GCD of 30, 36, and 84. GCD of 30, 36, and 84. So what are the factors of the numbers? What are the factors of three numbers? So we have 30, we have 36, and we have 84. So let's start with 30. We have 2 times 3 times 5. 36, we have 2 times 2 times 3 times 3. Let's confirm this. 3 times 3, 9, 9 times 2, 18. 18 times 2, 36. Okay, let's move on to the next one. We have 2 times 2 times 3 times 7. Let's confirm this. 7 times 3, 21. 21 times 2, 42. 42 times 2, 84. Now from this you can get our GCD. From that you can get our GCD. Now we'll find that our GCD is what? 2 and 3. So our GCD is 2 times 3, which gives us 6. But the question is asking, pieces of wire of equal length were cut from the 3 wires. Pieces of wire of equal length were cut from the 3 wires. Now we move on to the next step and divide each wire by 6. So we'll have 30 divided by 6. 36, sorry, plus 36 divided by 6 plus 84 divided by 6. I think you know why I'm dividing it, because on the last part of the question, you calculate the least number of pieces obtained from the 3 wires. So we have to add each piece to another. So dividing 30 by 6, we get 5. Dividing 36 by 6, we get 6. Dividing 84 by 6, we get 14. All of them sum up to 25. All of them sum up to 25 pieces. 25 pieces of wire. Okay, that is that. Let's finish it with one more question. Let's finish the session with one more question. Then I can give you an assignment on that to go and practice. Okay, one last question. A rectangular floor of a room measures 5.4 meters long and 4.2 meters wide. The room is to be covered. The room is to be covered with square tiles. The room is to be covered with square tiles. Calculate the minimum number of square tiles that can be used, to cover the floor. Calculate the minimum number of square tiles that can be used to cover the floor. Let's move on to our solution. Now let's analyze the question first. We have a rectangular floor which measures 5.4 meters long and 4.2 meters wide. So we have a rectangular floor there. It measures 5.4 meters long and 4.2 meters wide. Now the room is to be covered with square tiles. Now we are supposed to cover the room with square tiles. We are supposed to cover the room with square tiles. Okay. Now first of all, what do you know about area of a rectangle? Area of a rectangle is equal to length times width. Now multiplying the length times width here, we have our length as 5.4 and width as 4.2. So we'll do 5.4 times 4.2 meters. So multiplying that, we get what? Multiplying that, we get 22.68 meters. Get 22.68 meters. But since it is area, we put a square there. 22.68 meters square. Okay, now on to our next step. We will find the GCD of 5.4 and 4.2. So GCD of 5.4 and 4.2. Now let's find first the factors. Factors of 5.4 and 4.2. Factors of 5.4 and 4.2. Factors of 5.4 and 4.2. So we'll have 2 first to make it 2.7. 3 to make it let's confirm this. So here we have 3 times 3, that is 9. 9 times 3, that is 27. 27 times 3 times 2, that is 54. Okay, here will be 2 times 3 times, sorry about this, times 2 times 3 times 7. Okay, now from this we can get now the GCD. So our GCD here will be 2 times 3, that makes it to be 6. But since we are dealing with decimals from the factors, we'll make it to be 0.6. This is just one side of the square tile. We need to calculate now the area of the square tile. Now area of a square, you all know that is side times side. That makes now our area to be 0.6 times 0.6 meters, bringing us to 0.36 meters squared. 0.36 meters squared. Now we have found the area of the rectangle as 22.68. Please mark this, 22.68, and area of the square is 0.36. Now what we need to do now is now to find how many square tiles can cover the floor. Now we have area of the rectangle, as 22.68 meters squared. Area of square as 0.36 meters squared. Now our next step now is just to divide this by this. So you have 22.68 divided by 0.36. Both of them are in square meters. Sorry. We cannot express it that way because of some reason. Because we want to find the number of square tiles. So this and this be cancelled, also units cancelled. So dividing 22.68 by 0.36 will come up to our answer as 63 square tiles. 63 square tiles.